Hi, I'm Jiangkun from National University of Defense Technology. Today, I wanted to talk about the identification and the composition of anisodamping for the high Q factor resonator under whole angle mode. As for the low Q factor gyroscope, as you see in the finger, the identification method rely on the procession of the pattern angle towards the primary axis of damping. It's not effective and efficient for the high Q factor resonator because it would take a long time to reach the damping axis. Similarly, the anisodamping composition by the self-procession method is also impractical because the suppression rate is relatively small for the high Q factor resonator. Hence, therefore, the identification and the composition methods of anisodamping for the high Q factor resonators are of great importance to improve the performance of whole angle mode. The honeycomb disk resonator gyroscope is composed of 16 outer electrodes and several layers of inner electrodes. Stiff mesh decoupling achieved by hanging lumped meshes on the resonator is a key process for the design of HDRG to improve the Q factor. As you see in the figure, the decay times of the two axes can be improved to 47.455 seconds and 48.35 seconds respectively. Besides, the frequency mismatch without frequency tuning is less than 3 Hz. Apart from a honeycomb disk resonator, this whole angle platform also consists of two printed circuits boards. One PCB contains analog amplifiers for detection and execution of the resonator's vibration and mixed signal electronics, digital to analog converters and analog to digital converters. The residual part of is the FPGA platform for digital signal processing and implementation of the controllers. There are 3 control loops in this whole angle system. The A represents energy, which is kept as constant by the energy control loop. Q represents the quadrature, which is known by the quadrature control loop, and delta phi represents the phase difference between detection and action, which is used in the phase lock loop. The pattern angle theta can be calculated from the 0.5 octagent as divided R. The major effects of anisodamping under whole angle mode are angle drift. Therefore, the anisodamping can be identified by observing the angle drift. If we control the quadrature Q to 0 and consider the static case when omega equals 0, the angle drift rate can be expressed as theta bond equals 0.5 delta and sine. And from the figure, we can see the simulation results. We can get the theta tau and the delta 1 divided tau, which means we can get the locations and the numbers of the anisodamping. The parameters theta tau and delta 1 divided tau can be identified from the amplitude and the phase of the angle drift rate curves Afterwards, the experimental results are fitted to identify the amplitude alpha and phases beta, which represent the parameters delta 1 divided tau and the theta tau respectively. According to the fitted results, the theta tau equals 8.899 degree and delta 1 divided tau equals 0.00058 hertz. This identification value is very close to the estimated value above. As for the composition of the anisodamping, the force FQS is used to eliminate the effects of angle drift induced by the anisodamping. Then we can see the performance characterization. The nonlinear of the scale factor is tested under 27 rate points ranging between 1,200 degree per second. For average rotation rate, the gyroscope has acquired output data for 30 seconds with a sampling rate of 1 hertz, 1k hertz, 1000 hertz. As so in the finger, the scale factor nonlinearity has improved by 5 times from 5.38 ppm to 1.08 ppm after anisodamping composition. This kind of gyroscope is quite suitable for the high-speed rotation because the periodical drift can be averaged to 0. Hence, the maximum scale factor nonlinearity is distributed in the slow speed regions. HDR is also tested under room temperature for 1.5 hours with 1 Hz sampling rate. As shown in the figure, the bias instability has decreased by 5 times from 0.251 degree per hour to 0.049 degree per hour. Such an improvement mainly comes from the elimination of the angle drift after the composition of anisodamping. Okay, that's all. Thank you for the listening and waiting for your questions.